Hello everyone, today I'm once again presenting the solution to MIFMO 2026, but today I'll be presenting problem number 2. So last week I did problem number 1 and today I'll be doing problem number 2. And judging by the results, at least the table of the results, I think these problems were quite similar in difficulty. And at least for me, I'd say that problem 1 and problem 2 were the only problems that didn't require any further maths knowledge. So you could solve these problems fully when you're still in school. So let's get to the solution. Once again, I'll present the official one and the one that I thought of, but it won't be as different as for problem number 1. Okay, so let's get into the solution. So what do you do when you get this problem? Well, you read through the problem statement. So let S be the set of all positive integers that can be written as with this form, right? Or better not to mark this, but rather this form, right? Where A1 up to A10 are not necessarily distinct positive integers. And you see that we have 4 parts, right? This is part 1, this is part 2, this is part 3, and part 4. So for me, most of the time, the last part is just, well, maps everything together. So you see that in part 1, you prove that 1 is an S, you prove that 12 is an S, and in part 3, you find the largest element of S. And part 4 is just finding the set S. So if you do find set S, well, you've already done part 3, part 2, and part 1. So basically these first 3 parts are just guides on what you should really be doing. So basically, I think the most intuitive part is part 3. So I'm presenting the official solution, but with my own knowledge, I guess. So this statement, this part 3 was really what helped me start, and I solved this problem basically immediately. My write-up was not clean, but the idea was not that difficult. So find the largest element of S. So, well, what do we have? We have that all the elements of S are somewhat of this form, right? Plus 3A3 plus 4A4. I'll just write it out for the sake of simplicity. And looking at it, right? Oh, I missed. I swapped them around. And, well, what do you see? At least what I personally see, I swapped them around again. Well, AI is a positive integer, right? Belongs to positive integers. This is notation for just integers, and this is notation for positive integers, right? So how large can this sum be, basically? It is what it is asking us. And actually not that large, because each of AI, well, what do we want to do? We want to maximize, right? We want to maximize n. But so hence we want to maximize every fraction, right? Because they're not dependent of each other. So like a guide, basically what we want to do is we want to max n, right? But hence we want to maximize every fraction, so I over AI, But I is fixed, right? So we want to maximize 1 over AI. So we want to minimize AI, right? Because if we are maximizing, yeah, I think it's pretty self-explanatory. So, and this is the minimum positive integer is 1. So it is minimized when AI equals 1. So basically, we kind of have the intuition that the maximum is achieved when all AIs are 1, but we of course still need to prove it. So we could prove it by saying that, oh, well, I'll just proceed this sum here. N is less than or equal to what? Well, we can basically, we have that A over AI is greater or equal than 1. And if we divide by AI, we have that 1 is greater or equal than 1 over AI, right? And this is the same as 1 over AI is less than or equal to 1. So with this in mind, we have this. 1 plus 2 plus 3 plus 4 all the way up to plus 10. And you can just calculate this by hand, but this is just 11 over 2. Or you can use the arithmetic progression formula. This is 55. Or you can just add these numbers together, 11 and 5 groups with them, so 11 times 5, 55. Right? So we've shown that n is less or equal than 55, but also n can be negative and an integer can be 0, right? Because all of these inputs are positive integers. So also we have that that n is greater than 0. So basically we've shown that in order for, oops, we don't need 3 5s here. So what we've shown is that in order for n to be able to be expressed of such form, it has to come from this set, from this interval. But are we done? No, absolutely not. We still need to show that maybe some of these n aren't expressible. But when you think about it, it doesn't seem likely that they won't be, because you have everything in your power to make it basically whatever you want, because you can change A1, you can change A2, you can change A3. You have so much, how do you call it, degree of freedom that it seems so unlikely that somehow magically you won't be able to get, let's say, 37 or some number. So now in this place you just start asking yourself, okay, so how do I prove it? And okay, I'll show you my construction maybe first, because for me it was more intuitive, and then I'll show you the official one. So my write-up, my official solution has like 4 or 5 or 6 pages, but most of them are just scribbling stuff that just to be safe, right? And just to write everything up clearly. So, but today I'll not present it like super rigorously, but just explain the whole idea on how you would construct every number. So okay, let's start from the top. How do we construct n equals 55? Well, we take all AIs to be 1, right? This gets us 55. And what do we want to do now? Well, we want to get 54. So how can we twist this construction in order for us to get 54? Well, what do we want to do? We want to minimize it by 1, right? because this gave us 55, and now we want 54. So the thing is that we can just do this. We can pick all these numbers to be 1 and a2 to be 2. And this will decrease by 1, right? Because instead of 2 over 1, you will get 2 over 2. And we can actually do the same thing for other numbers. So for a1 up to a2, up to a4, up to a10, and we pick a3 to be 3. And we've minimized now the sum by 2. And you can claim that, well, it's not, yeah. You can claim that, oh, by doing this, basically we'll reduce all the way to a1 equals a2 equals a9 equals 1 and a10 equals 10. So by that time we'll have reduced, we'll get n equals wait. So right here we've minimized by 2. So we'll get n equals 46, I think, right? Yeah, that seems to be correct. And then, well, we basically continue this process. So until we get a1 equals up to a8 equals 1 and a9 equals 9, a10 equals 10. And we will have n equals 39. And then you basically just proceed this process until you get, and I don't think I've made a mistake. Yeah, I don't think I have. Until we get what? Until we get n equals 10, and we get that a1 is equal to 1, a2 is equal to 2, a3 is equal to 3, up to a10 is equal to 10. Right? So we get 10 ones. So if we come back to this, we'll basically have 10, we'll have 10 ones. And how do we proceed further? Well, you have two ideas, and mine was, well, what can we do? We have 10, and now we want to minimize by 1. Well, we kind of do the same thing, but if this was 1 and this was 1, how can we make it? Now, right now we have a 2, right? 1 plus 1 is 2. Could we maybe somehow get a 1 plus 1 half plus 1 half is 1? Well, yes, we can. Instead of a9 equals 9, we can just pick a9 to be 18 and a10 to be 20. Right? So, and yeah, we show that, oh, if from this we choose a9 and a10 to be, not equal, a9 to be 18 and a10 to be 20, well, we'll get n equals 10. And of course, the same numbers here. Oh, n equals 9, sorry. And, well, then it's basically just a matter of fact that showing that with halves, with fourths, with eighths, with sixteenths, you can get any integer up to, from 10 up to 1, from 1 up to 10. So, yeah, and then it's basically just, so getting 9, you will get that by 8 ones and 2 halves, right? 10 numbers in total. N equals 8, you'll get by 6 ones and 4 halves, right? This is 8. Well, the total sum is 8, right? 6 plus 2 is 8, but we've used 10 numbers. And yeah, it's just n equals 7, you'll get n equals 4 times 1 plus 6 times 1, 1/2, you'll get 7. n equals 6, you'll get n equals 2 times 1 plus 8 times 1/2, you'll get 6. n equals 5, you'll get n equals 10 times 1/2 equals 5. And basically we're almost done. N equals 4. So what do you do now? N equals 6 times 1/2 plus 4 times 1/4. And this is 4. N equals 3. You pick n equals 2 times 1/2 plus 8 1/4. We have 3. And we're almost done. N equals 2. What can we do? Yeah, we can do, for example, yeah, look, we can do this same thing. 2 1/2 plus 8 1/8. We'll get 2, right? And the only concern is that we always have to use 10 numbers, right? And for n equals 1, I think pretty much everything works. You can do, for example, 2 1/4 and 8 1/16. You'll get 1/2 plus 1/2, which is 1. Yeah, and in this fashion, you've constructed all integers from 1 to 5. So why is this problem done? Well, this was just not that good looking. It of course wasn't necessary for me to write it up. I just wanted for you to be, confident in that it does indeed work, and just to be rigorous. So what we've shown is we've shown that all n. So from this, right? From this, this implies that all n that can be written in this form, right, must be in this interval. And then we constructed every n from this interval to be actually expressible. And we're done. We could just write QED. Of course, we need to explain what we are doing here, but yeah, QED, and we're done. But the official solution was a tiny bit more different. The construction was somewhat maybe more simple. So the official construction was basically we induct not like from the top, but from the bottom, from n equals 1. So for how to get n equals 1, well, what's the sum? What's the sum of these numbers? The sum of the top of the fractions, the numerators, yeah, I think so, are 55, is 55, right? So if we pick all of the denominators, all of ai to be 55, well, we get that n equals 55 over 55, which is 1. And now it's just a matter of showing that everything else works. But, well, I won't write it out in detail because it's not that important, I guess. But what you do is, okay, then you ignore this number, you write a 1 here, and then you make this a 54. What you do then is you ignore this number and then you make this a 53, and you'll get 2 plus 1. Then you ignore this number, you just play around with these numbers, make all the denominators equal. So basically the construction is, so the number that you want, right? For example, you want k, and you pick a1, plus a2. Oh no, not a1. You pick what? Oh, you pick the first numbers that are less than k. Basically, are k minus 1. And then, yeah, you just pick the remaining numbers to have the same denominator, and then you get a 1. So basically, with some numbers, A1, not A1, AI, AJ, AM, up to some A sub T, you force these to be I, J, I plus J plus M plus T. You make this K minus 1, and with the remaining denominators, you force them to be something, yeah, some T over T. And you'll have K minus 1 plus 1, which is K. So yeah, of course, it's not in full detail. The official solution goes by, you first show that, well, you kind of already show that a short lemma that in the way that I've shown, you can quite easily construct all the numbers up to 10, or up to 11 actually. Yeah, you isolate this term and you make all the other terms equal, all the denominators equal, and you get some 10 plus 1 or 9 plus 1 or anything like that. And basically you then do an induction. You pick the largest k that is between the number, and yeah, you just write it up more neatly than this, of course. So I guess that's pretty much it for today. If you want to take something away from this problem, I think the main two things would be that, well, just try to understand the problem, because I've shown this problem to a couple of my friends, and well, their first idea was, oh no, it's an Olympiad problem, I won't be able to solve this, and they don't even try. Well, try it yourself. I mean, none of these ideas were super difficult. Well, you basically need one inequality that, well, by this chain of thought, it's not that hard to come up with. And yeah, don't be scared of solving them yourselves, of trying. Because yeah, after this inequality, you just need a construction. And as you see, there are plenty of constructions. I think you could come up with much more. And yeah, that's basically it. As I mentioned, don't be scared to try them yourself. And yeah, see you next time with problem number 3. Have a nice day.